In this video, we are going to explore one of Blackfire Profiler's most powerful features, comparing two deterministic profiles. If you ever needed to figure out whether the change you're about to make to your application can impact its performance for better or worse, then this one is for you. When you are developing a new feature or optimizing existing code, it's essential to know if your updates have inadvertently affected other parts of your application. Comparing profile helps you spot unintended side effects introduced by new code, validate performance improvements between two versions of the same endpoint, and prevent regressions by identifying slower function calls right away. Let's start by accessing your profiles in the Blackfire dashboard. Once you've run a few deterministic profiles, you will have them listed in your profile list. Here's how to compare any two of them. Look for the Compare button on the right side of each profile entry. Select a source profile, this might be the before version, and select a destination profile, the after version you want to compare against. Blackfire will then generate a comparison graph that visually highlights the differences in performance between the two. Once your comparison is ready, Blackfire displays a superimposed graph merging all calls from both profiles. You will notice the following. When a function call or node exists in both profiles, it's displayed as a single node. The node's background color tells you if the call is faster in profile B, blue, or slower in profile B, red. The number in that node represents the performance gain or loss, including all children calls within that node. Sometimes the paths between shared nodes differ. You might see nodes unique to profile A on the left side of the graph and nodes unique to profile B on the right side. These single nodes don't have direct counterparts in other profiles. As a result, their color coding and display numbers are not directly comparable in the same way as shared nodes. Performance changes are only meaningful for shared nodes, because that's where you have true apples-to-apples comparison. Here's how the calculation works. For shared nodes, the gain or loss is calculated by subtracting the time or resource usage of the two nodes. If the graphs diverge between two shared nodes, you can estimate the impact by looking at the first shared node before the split and the next shared node after the split. The difference between these two shared nodes will help you understand the performance impact of that divergent piece of code. Here's a quick tip that can help you make effective comparisons. Make sure to name or label your profiles so you know exactly which version of the code or environment they belong to. This will help you organize your comparisons and remember the profile context when you need it.